Hello, everyone. In this video, we are following chapter F4.2, Aggregating Images for Time Series, from the book Cloud-Based Remote Sensing with Google Earth Engine. We'll try to go through the concepts and also check the codes provided in this chapter. In remote sensing, we have the repeat observations. And we have the intervals between the two observations. And these observations can vary widely. We get the first observation, and there is some time gaps, and then we get the new observations. So different data sets have different intervals between those observations. For instance, we have the global precipitation measurement data set, where we get the observations of rain and snow worldwide every 3 hours. We also have climate hazards group infrared precipitation with station, that is chirps. And this is the grid global dataset at the daily level. And we also have this dataset every 5-day period. We have the popular Landsat 8 dataset, where we get the data every 16 days. Then we have the Sentinel-2 mission, and we get the images for every location every 5 days. So we can see that different types of data have the different intervals of the observations. But the requirement for the remote sensing analysis is that we need to aggregate those data at the required time interval period than those data sets were initially produced. For instance, if we want to determine the rainfall anomalies, then it will be best to compare monthly rainfall against the long period monthly average. In that case, we have to convert this chirps dataset or the rainfall dataset into the monthly available images or monthly available datasets. Other case will be an example where we need to get these cloud-free time series images. And this is important for many applications. And when we, on how we do this is we can aggregate that data by month, by season, or even year from all those individual images. And then we finally get one single cloud-free images. And the importance is also there where we need the yearly median composites, that is to get the median image. And this median image is free from clouds, free from noise, and we can detect any types of changes, any type of change patterns across those long time intervals. And this chapter shares us the codes to aggregate individual images from the time series at the chosen interval. We are given with this example where we get to know this chirps data set and we get the monthly rainfall time series. So let's dive into the code. Here we begin with the assigning this unique ID or the image collection to this variable named chirps. And then we have the start date and index. And then we are filtering this chirps dataset with dot filter. And this is done by dot filter, inside which we have the ee.filter.date. And we give this function with start date and index. So there are different ways to filter the dataset in Earth Engine. So this is one of it. And then we can print it. And we can see that in the console we have already printed this. So what we get is features. We have 72 different elements, and inside which we have the bands, that is precipitation. So this is the first way, and we can see the time as well. For instance, this one is available at the first of this month. Then we have some gaps. So this particular data set is about it's available every 5 days. So this is basically the penta data set. That means we will have the images every 5 days. You can see this is 1, then plus 5, 6, plus 5, 11, and so on. Then we see the next section. Here we do the same thing again. We assign this image collection to this variable, chirps. Then we have the year as 2019 to this variable year. And here we have this ee.date.from_ymd. And in this takes the variable year, and this is 1, 1. So basically what it does, it kind of converts that year into the first day of that year, first day, first month of that particular year, just to convert that whole year into the full date. Then we have this next function here, .advance, and it basically advances the year by 1 unit here. And whenever we need this, we can go to the doc section and we can read and understand what this function does. Then again, we do the same thing. Here we have the image collection. Then we filter by the start date and index, and then we can print it. We just saw this before, and then we can see the start date and index here. Then here is the important one. This is the .milli milliseconds. So this is the way to convert the date into the timestamp. So what it does, it takes the date object and it returns the number of milliseconds since the arbitrary reference date of the start of the year, that is 1970. And this is called the Unix timestamp. And this is the kind of standard way to convert dates to numbers. So this is basically the milliseconds from the initial year, 1970. So how many milliseconds have passed from this time to this current date? And it gets us the milliseconds. So we get a very large number here. So this is basically the milliseconds. And this is the quite efficient way or the standard way to convert dates to the large numbers. Then here we have the important way. This is the main thing in this chapter. So basically what we do is we took the pentad images. We get the images every 5 days, but that is not enough. We want the images to be available monthly. For this case, we are doing this process here. So what we do is we have the months here, variable name months. Then we are sequencing it by 1 to 12. And this function gives us the list of numbers from 1 to 12. This gives us the sequence that increases by 1 unit from 1 to 12. This is assigned to the variable name months. And here we are creating an important function. So what this function does, it takes some beginning month here, and inside which we have the start dates. So it gets that year, and then we have the beginning month. And so this will create a first date, and then we have the end date. This will just take the start date and advances it by a month. Previously, we saw this as year. Just a few seconds before, we saw this as month here. This is the same. In this case, we want to advance by a unit of year, but in this case, we have the month. And again, we are filtering this by .filter. And then we have this start date and index. So this will be filtered by start and index. And then we get this month filtered variable, and this will be reduced further by .reduce. So we will reduce to get the summation of all the precipitation occurring within that time frame. That is for the month. And then we provide the time properties here. Again, the start and index will be given this as by .milliseconds. Then we have the year. So this will be stored in this variable as the properties. Now we create the monthly images. We write the months, and we will map this function that is .map create monthly images. And what we get is the and we further convert this into the image collection by ee.image collection dot from images, and we get the image collection. This time we have only 12 images, so we got our monthly images. So this was the, and if you see this year filtered, it just from this, it's just outside this function. So this was created earlier here, year filtered. And then we have the final section where we print the chart here. So this is our area of interest. This is the point from where we want to build the chart. So this is the geometry here, somewhere in India. Then we have this chart, ui.chart.image.series. C is capital here. Then we provide the image collection. For this reason, we want to do the mean. So basically, this is to reduce the images by mean. We get the mean rainfall there, and our scale is this. So this is the highly available only data set that is in high resolution compared to all the other data sets for the rainfall data set. So this is the highly available rainfall data set. So this is the unit 5566. Then we print the chart, and what we get is this one. And we can add more information and try to make this chart more informative. And this is done by dot set options, where we provide some other parameters such as line width 1, point size to be 3, and we also give this title. We'll have the information in the vertical axis. Then we have the horizontal axis as month. What you see is this here. So this time we get some titles, and we also get some vertical title in the vertical axis, also in the horizontal axis. And this is the monthly rainfall. And if we click here, we get this chart in the new tab, and we can download this as CSV as well. So this is the chapter F4.2, very helpful. And these functions are very much applicable to all other datasets as well. So we talked about this global precipitation measurement dataset. We also talked about Landsat emission and Sentinel emission. So these functions can be repeatedly used, or also can be modified for other cases as well. So very helpful chapter. I hope this was helpful. Thank you for watching.